Hi guys, welcome back to another video. In this video, we are going to be solving the question of finding maximum number of events that can be attended. So in this problem, we are given an array of events where a particular event can be denoted by a start day and an end day. So for example, there could be an event that is starting at day 1 and ending at day 8, and another event which starts at day 2 and ends at day 3, and another one could be 4, 5, and these start and end days are such that the end day is greater than or equal to start day, and we can only attend a particular event on one day. So for example, the first event starts at day 1 and ends at day 8. So we can only attend this event on one day between 1 and 8, both inclusive. So for example, we can attend it at day 1 or day 2, day 3, or and so on till day 8, but we cannot attend it on more than one day. So we have to pick one day between 1 and 8 to attend this event, and once we attend a particular event on a particular day, then we would be done with that event and we are never going to process it ever again. And we have to determine the maximum number of events that can be attended. So if we take a simpler case, for example 1, 2, 2, 3 and 3, 4. So this is a really straightforward case, and for this one we can attend the first event on day 1, we can attend second event on day 2, and we can attend third event on day 3, and this way we would attend the maximum number of events, and the maximum number of events in this case is equal to 3. So let's have a look at an example and try to understand brute force solution for this problem. Let's say we have this example, and in this example we are given 6 events with start days and end days. In this example, as you can see that the events are not really ordered. So as you can see that there's one event which starts at day 5, and there's one event which starts at day 10, and then we have this event which starts at day 2 and ends at day 2. So these are not really ordered, and we have to figure out how we can determine maximum number of events that can be attended. The first step to determine here is to find the minimum value of start day and then find the maximum value of end day. So we have to find d minimum and d maximum. This d minimum is the minimum value of start day across all the events, and this d max is the maximum value of end day across all the events. To find the value of d minimum, we have to iterate over all the events and find the minimum value of start days. So we have to find the minimum value among this start day 1, this 2, and all the way this value 2. And for d maximum, we have to find the maximum value of end days. So we have to find the maximum among this value 5, 4, and all the way till this value 2. So if we do that, our d minimum is going to be equal to 1 and our d maximum is going to be equal to 15. So now we know the minimum value and maximum value of the days. Once we have found the lower bound and upper bound on the days, then we have to assign a particular event to a particular day, and there can be a case when no event can be attended on a given day. We can iterate over all of our events and find the event which has the earliest end day. So let's say we are at day d between 1 and 15, and we have to determine which event can be attended on this day. And also we can only attend a particular event on a particular day. So once we have attended an event on day d, we are never going to process it ever again, and we will not consider that in our iteration. So for that, what we can do is we can maintain a Boolean array, and let's call it used. And once we attend an event at index I, we can simply set used I equal to true, and we can check this boolean when we are finding the event which can be attended on day d. To determine if an event at index I can be attended on day d, we have to check if start time of that event should be less than or equal to d and end time of that event should be greater than or equal to d. This condition would ensure that this event can be a potential candidate of being attended on day d, and if that is the case, then we have to compare this event with other potential candidates, and to compare with other potential candidates, we have to maintain a global variable for those potential candidates, and let's call it earliest end time. And if the end time of this event is less than earliest end time, then we can set the earliest end time to be equal to end time. And we also have to maintain a value to store the index of chosen event. So let's call this chosen event. And for the case when end time for this event is less than equal to earliest end time, then we can set the chosen event equal to index I. And once we are done iterating over all these events for this day D, then we can check if chosen event is not equal to -1. Initially we can set this one to -1, and if it is not equal to -1, then this means that a particular event was selected on this day D, and then we can set used I equal to true and increment the value of maximum events. And when we are iterating over our events, the first check we are doing is whether that event has already been used or not. If it has been already used, then we can use a continue statement and move on to the next event. I hope this idea made sense and it was straightforward to understand this, and it would make more sense when I explain the coding implementation for this one. The time complexity for this brute force solution is going to be equal to O of D times E, where D is the number of days and E is the number of events. The next question to ask ourselves is, can we do better? So the answer is yes, we can do better and improve our algorithm and solve this in O of E log E using a min heap approach. So let's have a look at our min heap approach. For our min heap solution, the first thing we are going to do is we are going to sort the events based on their start times. So in this example, we have these 6 events and I have already sorted them based on their start times. So these events look something like this. We have 4 events which have the same start days and end days, and these events have start day as 1 and end day as 3, and remaining 2 events do not overlap with any other events. So in our min heap, we are going to store the event which has the minimum value of end day at the top of the heap, and this way we are going to maintain a min heap based on the value of end day. Initially, to iterate over the events, we can use an index and set it equal to 0. So let me call it current index, and we can set it to 0, and this index will help us iterate over all the events, and these events are sorted based on their start days. As discussed from our previous brute force approach, we need to start from some day and we need to start from minimum value of the day, and in this case the minimum value of day is equal to 1, and for that we can use another variable, and let me call this lower bound. We can either set this lower bound equal to 1 before entering the loop which iterates over all the events, or we can set our lower bound when min heap is empty. So min heap is going to be empty when current index is equal to 0. So what lower bound really denotes is the minimum value of day among all the events which are remaining to be processed. So when current index is 0, the remaining events are all these events, and there could be a case when we have processed first 4 events, let's say, and there is some gap in the number of days between the end day of this event and start day of this event, and due to this gap our min heap can be empty, and for this case we'll have to set lower bound equal to 5. So lower bound denotes the minimum value of start day among remaining events, and when min heap is empty we can set lower bound equal to events current index, and we have to set it equal to start day, and it would be index 0. So this way we can set our lower bound, and when current index is equal to 0, our lower bound is equal to 1. So now what's going to happen is current index is 0, and now we're going to check the start day of a particular event with this lower bound, and by comparing these values we check whether a particular event is a potential candidate of being attended on this day D, which is this lower bound. So the start day of an event at index I has to be less than equal to lower bound. And if this condition is true, then we can add this particular event to our min heap. So we can add this event 1,3 to our min heap, and we can increment our current index by 1. And now we will move to our next event and will come at index 1. So event at index 1, its start day is also less than equal to lower bound. So we also add this event to our min heap. And now we again increment our current index, and current index becomes equal to 2. And now we come again at an event which has same values of start day and end day, and start day of this event is less than equal to lower bound. So we have another event 1,3, and now we again increment our current index, and for this event also start day is less than equal to lower bound, and we again add another event to our min heap. So far we have 4 events in our min heap. Now we again increment our current index, and current index becomes equal to 4, and now we come at an event which has start day as 5 and end day as 7, and in this case 5 is not less than equal to 1. So we cannot add this event to our min heap since the events are sorted based on start times. So we can break out of the loop and we don't need to iterate over remaining events. Now next check we do is we check if our min heap is empty or not. If our min heap is not empty, we are going to do a poll from our min heap. So polling from this min heap is going to give me one of these events. So it's going to give me 1,3. And now what we are going to do is we are going to increment our value of lower bound, and incrementing our lower bound is going to make it equal to 2. And also we can increment value of maximum number of events. So initially we set that to 0, and incrementing it is going to make it equal to 1. What this polling operation means is that we have assigned this day 1 to this event 1,3. And that is why we have incremented value of max events. Since we can only assign one day to one event, that is why we only do poll of one event. Now the value of lower bound is equal to 2. Now we are going to resume our iteration over remaining events. The value of current index is 4. So now we can check if start day, that is value 5, is less than equal to lower bound, and lower bound is 2. So this is false. So we break out of our loop and check if our min heap is not empty. So our min heap is not empty because it has 3 events in it. So we do a poll operation. So poll operation is going to give me another event which has start day as 1 and end day as 3. And what this means is we have assigned day 2 to this event. And once we have assigned a particular day to an event from our min heap, we are going to increment lower bound, which now becomes 3, and maximum number of events, which now becomes equal to 2. And once we do that, we are going to resume our iteration over remaining events. And again we come at this event where current index is equal to 4, and for this case 5 less than equal to 3 is false again. And now we again come to the condition where we check if our min heap is not empty. So our min heap is not empty, and we are going to do a poll operation from our min heap, and we are going to assign day 3 to another event which has start day as 1 and end day as 3. And once we do that, value of lower bound becomes 4 and maximum number of events becomes 3. And now something interesting happens. Now the lower bound value becomes equal to 4, and our min heap has an event which has an end day with value 3. So we cannot really attend this event now because lower bound has exceeded its end day. So what this means is that this event is a stale event. So after we assign a particular day to an event, we do one more operation, and that operation is to evict all the stale events from our min heap. And to evict all the stale events from our min heap, we simply keep polling from the min heap as long as the end day of the topmost element is less than the value of lower bound. And by doing this, we make sure that there are no stale entries in our min heap. So we have to evict this event 1,3 from our min heap, and now our min heap is going to be empty. And once our min heap becomes empty, we have to reset the value of lower bound, and value of lower bound is going to be minimum of start day among remaining events. So the remaining events are these two events, end day as 7 and another event with start day as 8 and end day as 9. And in this case, lower bound is going to be set as the start day of the event at current index. So current index is 4 and start day is 5. So value of lower bound is going to be equal to 5. And now we check whether start day is less than equal to lower bound, and that is true. So we add this event to our min heap, and now we increment the value of our current index, and it's going to become equal to 5. And now we check if 8 is less than equal to 5, which is false. So we break out of the loop, and now the next condition is going to be checking if our min heap is empty or not. So our min heap is not empty, and we can assign this day 5 to this event 5, 7. So as you can see that after assigning day 3 to an event, we are only able to assign an event to day 5. We did not assign any event to day 4 because we cannot attend any event on day 4. And once we do this assignment, we are going to poll from the heap and increment value of max events. This is going to be equal to 4, and increment the value of lower bound, and this becomes equal to 6. Now again our min heap becomes empty, and now there is only one remaining event. So we set our lower bound as the start day of this remaining event. So now it's going to be set as equal to 8. And again we check if start day of this event is less than equal to lower bound, which is true. So we add this event to our min heap, and after adding to the min heap, we increment the value of current index. Now current index will become equal to 6, which is going to be out of bounds value, which means that we have processed all the events. So we are going to break out of the loop, which is being used to iterate over all the events. Next condition, we check whether our min heap is not empty. So our min heap is not empty, and we are going to assign this day 8 to this event 8, 9. And once we do that, we increment the value of max events equal to 5, and increment the value of lower bound, which is going to be equal to 9, and also poll from our min heap. Now our min heap is empty, and we have also iterated over all the events. So we can simply return the value of max events, and our max events is equal to 5. So we return this value 5, and we would be done. Now let's try to understand the coding implementation for this problem. So this code is for our brute force solution. So as discussed from our brute force solution, we first need to find the lower bound and upper bound on the days. So I defined these two variables, lower bound and upper bound, and I set the lower bound to max value and upper bound to integer.min value, and I created a max events variable and set it to 0. And initially we're just checking if events length is 0, then we are simply returning 0. And in this for loop, for our lower bound, we have to find the minimum of start days. So we iterate over all the events and set lower bound as the minimum value. And for upper bound, we have to find the maximum of end days, which is at index 1. So we do a maths.max operation and set our upper bound. Next, we create our boolean, which is used to track if an event has already been attended. And next, we have this for loop, which iterates over all the days and assign an event to a particular day. This inner for loop iterates over all the events, and among all the potential candidates, it finds the event which has the earliest end day and sets that event as the chosen event, and also sets the value of earliest end day. And once we iterate over all the events, if this chosen event value is not equal to -1, we set that events index as true in our boolean and increment the value of maximum events. And when we are iterating over all the events, we are also checking if an event has already been attended. If it has been already attended, then we simply move on to the next event. And in the beginning of our outer loop, we set our chosen event as -1 and earliest end day as max value. We set this as max value because we are finding the event which has the minimum end day among potential candidates. And at the end, we simply return the value of max events. So let's try to run this one, and this one got accepted. So if I try to submit it, it is going to give me time limit exceeded. So let's not submit this one, and let's now move on to our min heap approach. Now moving on to our min heap solution, So in the beginning, again, we are checking if events length is 0, then we simply return 0 because number of maximum events would be 0. And as discussed from algorithm walkthrough, we first need to sort our events based on their start days. So this code does that. And next we initialize our min heap. And after initializing our min heap, we set our lower bound equal to the minimum value of start day among all the events and initialize our max events and current index as 0. And moving on to our main coding logic, this is the while loop which handles the main logic. In this while condition, we are checking the index that iterates over our events, and also we are checking whether our min heap is not empty, but we have an OR operation here, which means either of these two conditions must be true. And inside our while loop, first we check if our min heap is empty. If our min heap is empty, then we have to reset our lower bound and we have to set it as minimum value of start day among remaining events. And this is the loop which iterates over our remaining elements. That is why we start this loop from our current index, which means that we are iterating over remaining events. And in this loop, we check if start day is less than equal to lower bound, which means that this event is a potential candidate of being attended on this day. So we simply add it to our min heap and increment our current index. If it cannot be attended on this day, we simply break out of the loop because the events are sorted based on start days and it does not make sense to iterate over next events. We can also call this lower bound as current day, as it denotes the current day that we are processing. And once we iterate over these events, next we check if our min heap is not empty. So what this means, if it is not empty, then it means that we can assign the current day to the topmost event in our min heap. So q.poll operation does that, and now we increment our current day and increment the value of max events. And after this if check, we need a while check to evict all the stale entries from our min heap. This is necessary because we incremented this lower bound, and if this lower bound got incremented, then there can be stale entries in our min heap. So we have to evict them in order to keep our min heap in sync with the event being pointed by this current index. So that is why we need this poll operation here. And there can be a case when our min heap is not empty and we have processed all the events. So that is why we are going to need an OR operation here. And once we are done iterating over our while loop, we are going to return the value of max events and we would be done. One thing to note is that we can also do this stale entry eviction before our if check. So let me copy this and move it before our if block. So this is also fine. I highly recommend you to draw diagrams and verify that the ordering of this while loop and this if block does not matter. So let's try to run this one. So this got accepted and let's try to submit, and this one works, which is great. And also let me copy this if and move it above while. Now let's try to run it. So this one works and submit, and this one also got accepted, which is great. So I hope this made sense. If you have any doubts, let me know in the comments and I'll see you in the next video. Thank you for watching.